Assalamu alaikum everyone. I hope you guys are doing well and you had a nice weekend. I hope you did the questions that I assigned to you. And so we completed experimental techniques, which is a major chapter when it comes to especially your ATP. And now we are moving on to understanding what these things are and what things are made of. Now, the first thing that we need to know about that is that remember I told you that there is this uh, idea of substances being there. Like substances are what things are made of, and we said that we also used another word, and we said that those substances are made of particles. So on one side we have substance, and on the other side we have particle. Now, the difference in these two is that substance is something that you can interact with. You and me can interact with it, maybe, and it might be dangerous, it might be useful, it varies from what that substance is. It can be cold, it can be hot, it can be heavy, it can be dense. All of those things basically define that substance, and these are physical qualities of that thing. It might have a high melting point. Maybe I can make wires for conducting electricity from it, or maybe I can use it to coat those wires so the current doesn't go or doesn't electrocute anybody that's using with them. But they are all basically substances. But at the heart of it, they are all made of particles, as kinetic theory says. And these particles aren't hot or cold, or they aren't dense or conducting electricity and all that. The particles don't have any of those properties. They're all properties of substances. But interestingly, and that's remarkable, that all of those properties actually come from what those particles are. And if a certain kind of particles, a certain number of those particles come together to give those properties to the substance. And of course, it has to do with kinetic theory, which beautifully explains it, very brief points that tell us what they are. Now, of course, I will go through these two things, and this is a work in progress. But let's see, at the heart of it, we divide substances into those that are pure and those that are impure. And again, from a chemist's perspective, purity is when something is made of only one kind of particles. That's what purity is. And particle is basically what makes everything up. What those particles are, we don't really have to get into that for now. Similarly, when we talk about pure substances, we talked about that there is a way to know if something is pure. Melt it, if you're able to do that. And if you melt it and it melts at a fixed temperature, that is a fixed melting point, it's a pure thing. It has a fixed boiling point, that's a pure thing. It gives a one spot on the chromatogram, it's a pure thing. And impure things will obviously not show that. Pure things, we further divide them into element and compound. Now, some students think that compound is not a pure thing, but technically it is, because it's made of only one kind of particles. That's what pure things are. And impure things, we say that those are mixtures. Now, this can further be divided. For example, elements, we divide them into metal, non-metal, metalloids, and some of them can be radioactive. We talked about what radioactivity is. And compounds can be divided into those that are made from metal and non-metal, and those that are made just by non-metals reacting together. So compounds come from that. Then we have further categories of compounds that behave in a similar way. For example, in elements, we have nonmetals, and we have halogens, we have noble gases. In compounds, we have similar groups. We have acids, we have bases, we have salts, we have oxidizing agents. Those are all categories of different compounds based on their properties. We have conductors, we have insulators, obviously. In mixtures, we have a word that we use is solution. And solution is important to understand because solution is what has solute and solvent, and we'll spend a great deal of time on this today, that how do you make solution and all that. Then we also have suspensions. Suspensions are mixtures that are visibly separate. So there's parts of it that you can visibly see that they are different, and in solution that's not the case. In the solution, solute and solvent, you can't visibly differentiate between them. There is a third kind which is called colloid, but in O levels or IGCSE we won't deal with that. So these are the main categories of what mixtures are. And today our goal is to know how to convert a mixture uh, things that are physically mixed together, that are in proximity of each other, and convert those to pure things, how to separate them. And when you go from mixture, when you go from impure to pure, that part is called purification techniques. And that is what we're going to work on this. Of course, I will be working on this tree that we have here, and it will grow as we move further in the syllabus. All right, so we are clear about our purpose today. Our purpose is to understand how to separate mixtures, impure things, and convert them to pure things. Now, the method that you choose, the choice of that method of separation, it depends on the nature of the things that that the substances that you're separating. All the methods that we have, all of them, they rely on some difference that these things have. They need to have some difference of some sort. Usually it's a physical property, and we use 5 differences to separate these things from one another. Now, those 5 differences, we basically use them all the time. Those differences, as I told you, they're physical differences. So for example, there's the idea of solubility. When one thing mixes into another and they make one solution, that's solubility. But of course, if something doesn't mix with another, it is immiscible. That's another term. So I'll write the words here. Immiscible means liquids that don't mix together. Usually it's because of difference in density or forces that they have. There's obviously the opposite of that, miscible. If you have a solid that dissolves, that is usually called soluble, or again the opposite is insoluble. So immiscible for liquids, miscible for liquids that mix together. Insoluble for solids that mix into a liquid, and soluble solids that do not that actually mix in a liquid, and insoluble that don't. So that's a term that we use. Similarly, there's the idea of differentiating based on boiling point. That's another physical property of things, that some things have low boiling point, and we know that that's because they have weak forces of attraction, and some things have high boiling point, so that comes from there. Then there's the idea of density. Again, density is closely related to solubility. There's the idea of particle size. Is this a big thing or is this a small thing that we're separating? And maybe we can separate them based on their relative size, their size compared to one another. And after that, we have the last method, which is magnetic properties. That is this thing magnetic or not? Does it respond in a certain way to lodestone or other magnets that we have, and maybe things that don't? So there are only a few of them that actually show that. So this is magnetic or not. I'm having some technical issue with my pencil. Just give me a minute to fix that. Yeah, sorry about that. Yeah, so then we have magnetic separation, and some things respond positively to magnetic attraction and some things don't. So that's the 5th kind of difference that we have, and we are going to work with them. Obviously, solubility, where does it come from? That's forces of attraction, which we'll talk about later on in bonding. All right, so we have a few techniques that we use to exploit this to understand what these things are and how we use them. And based on this difference, you will be able to separate stuff. So now I'm going to talk about the techniques that we have. So there are multiple techniques. There is a technique that's called dissolving, filtration, and separation and crystallization and all that. Now, examiner expects a certain keywords that you should write whenever you're talking about these things. Okay, so it's important that whenever you're answering them, you talk about those keywords as well. Yeah, so the first one is, what if I have the age-old method of sand and salt? But technically, I'm not really concerned with sand or salt, or these chemists, they don't really go around trying to separate sand and salt. The basic idea is that sand is something that is insoluble and salt is something that is soluble. Now, I could simply replace these with some soluble or insoluble thing. Like, what if I want to separate silver chloride from silver nitrate? That, if the examiner gives this to you, what you should come think about is sand and salt, because to you, the only difference that they are showing right now is the difference in solubility. So the first step that we have is to exploit that difference. The difference is in solubility, right? So we dissolve them. So you add water. That's the first step. You add water. That is called dissolving. Now again, why am I using water? Because water is the solvent in which these are soluble. I don't really have to. I could use propanone, I could use alcohol, I could use diesel, petrol. It depends what kind of solution I want to make and what solvent I need. So sometimes we use water, sometimes we don't. So this is basically representing any solvent that you want. All right, so remember, the big idea is to separate things based on solubility. So obviously I have a solvent. Now, when I do that, we would want to stir it. Stirring helps in dissolving it. So we use a glass rod for stirring. Remember that. We don't use thermometer, we don't use spatula. We use a glass rod for stirring. Okay, but in O levels, they don't ask you to name them. Sometimes you might be asked to label it. All right, now we've added it, we've mixed it. What we'll have now is basically some beaker or some conical flask for mixing two liquids. If you have two liquids, we use conical flask. If you have two solids, we use beakers. And if you have two immiscible solids, we use separating funnel. So three choices of glassware that you have. So this, if you have two liquids that you're mixing together, and separating funnel looks something like this. And it has an open head and it has a tap at the bottom. So this is for immiscible solids. Okay, so what's happening here is that this might be useful for oil and water, and this might be useful for acid and base maybe, and this might be useful for silver chloride and silver nitrate. So three different glassware, three different apparatus that we use for mixing. Conical flask, it has a narrow neck, so you can just hold it and swirl it to mix those things together. We also use it sometimes to mix a solid with a liquid. If you want to react that solid, for example, magnesium, and I want it to react with HCl, I would pick this conical flask. Okay, so now I'm able to separate things based on this. What this is exploiting is density or solubility, both of them. So what's happening here is that I have oil and water. Oil doesn't dissolve, it has lower density, so it makes a layer at the top. So once we open the tap, the water is going to run out. So because that's a more dense thing, it's going to run out. I'm going to close the tap when most of it is gone, and then I'll be able to separate oil from there. Now this is used in many organic reactions whenever we want to separate a mixture of organic things that are made, and we use it all the time for those processes. And when it all obviously depends on the density of things being different. Then you have silver chloride and silver nitrate. Let's go back to this example. So they've dissolved, but silver chloride, which is a white solid, will be left over, and it might sediment at the bottom. How do I separate this? So that was my first step. I added water, dissolved it, stirred it, so it dissolved. And now what I'm going to do is I'm going to use this beaker and I'm going to pour it through a funnel. So this is my next step, okay? I'm going to pour all of this through a funnel, okay? And now what happens is that as I pour it, You might want to use a glass rod to help in pouring. Just make sure that you pour it right away. Kill that adhesive force of attraction. Just pour it. Don't slow down, otherwise it will start to drip, and some chemicals can be difficult to deal with if they get onto your skin. So just pour it. Just do that right away. Should be a swift action. Okay, so now the solid will be collected over here. What difference am I exploiting here? The difference I'm exploiting is particle size. So basically, the filter has pores in it. Filter is like a small gatekeeper. It has gate, and some things can pass through that hole, and most things, bigger things, will not. So that's what happens here. So the solid is left over. Of course, because I'm using a solvent, this solid will obviously have some traces of that liquid on it, and I will get the thing at the bottom which we'll call filtrate. Now that's a keyword. That's a word that in IGCSE sometimes they ask that what is a word used to label the thing that comes out of a filter paper or after filtration. That's filtrate. That's something that has passed through the gates, the holes in the filter paper. Okay, now my choice is a fork. Do I want to collect the residue, which is this thing, or do I want to collect the filtrate? And second, what do I want to do with it? Do I want to dry it? Do I want to crystallize it? What exactly is my goal here? So for that, we have a few keywords. So here's the thing. If you're interested in the residue, then what do? You just take the filter paper and you dry it. So dry, but before you dry it, you might want to wash it, because what if there is an impurity left over? So wash, usually with distilled water. If you're using alcohol, with alcohol. So wash with, usually in O levels or IGCSE, wash with distilled water. That's the first step. Second step, dry it. Now, how do you dry it? You can dry the thing into you can dry it in sun, you can dry it in an oven, you can dry it in folds of filter paper. Okay, so that is another thing you can do. All right, so that's what you want to do if you want to collect the residue. Now, what if I don't want to collect the residue? What if I'm actually interested in the filtrate? So again, with the filtrate, I have a choice of two things. Either I can crystallize it, sorry about the spellings, or I can get pure dry powder. Okay, now it depends on what the question is. If the question has asked me to crystallize the thing, then what I will need to do is basically heat it. Take the filtrate, pour it into something that is usually has a higher surface area, and heat the thing, because now your solvent is going to evaporate. But you have to make sure that you heat it slowly so that not all of it goes rapidly away. You might want to hold on to some of them because you want to make crystals. So here's the thing. What do? We heat to saturation point. That's a keyword we use again. Saturation point is when the substance is a saturated solution, that at that temperature, you can't dissolve any more of the solid in it. So you will start to see probably a few powder pieces. So stop right there. So first step is to heat to saturation point and then slowly cool it. And that's how candies are made. Basically, you heat it to saturation point, and that is when no more solid can be dissolved. And then you slowly start to cool it, and the hot or warm liquid keeps on evaporating, leaving some crystals behind. The slower you do it, the better the crystals. So that's crystallization. If you want to get crystals, sometimes they say outline the method or devise a method to get pure dry crystals. So that's how you do it. You heat to saturation point, then you slowly cool. With pure dry powder, what do? You just heat it. You just heat it, and you don't care whether you're going to reach the saturation point or not. You just heat, and the keyword is constant mass. So heat to constant mass, and that is how you will know that you have found pure dry sample, because now you don't care about the solvent, you just evaporate it. So that is how you get three different ways of getting different particles, different substances from silver nitrate or silver chloride or sand or salt, basically things that are soluble and things that are insoluble. So that is our first technique that examiner usually asks us about. Sometimes they give us a question of 3 or 4 marks about outlining these methods, and if it is only about the residue, then it's usually just a 2 mark or 2 or 3 mark question. And again, that is residue, that is something that is insoluble, and we use it when we make precipitates. That part will come later on, and precipitates are residues that are insoluble, so we use it for that. Okay, so that is the method for this. What if I don't want to just evaporate and lose that liquid? What if I actually want to hold on to the what you call the solvent that I have? I'm sorry, my pen is not working, so I'm just going to convert this to an oral lesson now. All right, so what if I actually want to hold on to whatever my solvent is? In that case, I will try to make sure that my solvent, I'm able to collect it back. All right, I want to do that. And that is a method which we call distillation. Now, here's a diagram to represent what distillation does. Yeah. Sorry, I can't really see what's happening here. Technical difficulties. All right, so let's look at this one. What's happening is that I have a boiling flask. Notice the round bottom flask, that's usually used for boiling. We heat it, we have a mixture. In this case, this is salt water. I'm heating it. Obviously, salt water has salt, which is soluble, and water, that's the solvent, and I want to collect the solvent. It's a pretty straightforward example. We heat it, water goes up, and then we have a condenser. I told you in the last lesson how you connect the condenser. Wherever you want the liquid to come out, that is where water in should be. Now, of course, I'm able to collect water like this because water can be cooled down by using cold water, right? But what if I wanted to evaporate, let's suppose, diesel or something that is that's boiling at a very high temperature, and if I want to collect that, let's suppose there's something that boils at 150 degrees Celsius. Now, water will not be a good coolant for that. I might want to use a different coolant because water will evaporate by the time that thing comes in. All right, so that's important. Now, on this, there's another idea that you need to know about, that is what source of heat to use. Now, sources of heat can be of two kinds. Ones that use a flame to heat them. Bunsen burner is one of them. The other that don't use a flame. For example, we could use a water bath. Water bath is when you have hot boiling water and you put something in there. Now, obviously, water is going to transfer its heat to that and it's going to heat up through conduction, and there's going to be convection current and all that. You study that in physics. So water bath is when you have hot warm water and you put something in there so that there's indirect transfer of heat. You could also use sand bath, which is, I haven't really used it, but I've seen it in some of the older papers. Sand bath, it's acceptable answer, I guess. And thirdly, you can use an electric heater. Electric heaters or hot plates, they're used all the time when you don't want to use a flame. Why wouldn't we want to use a flame? Because the thing is flammable. For example, now here's the thing, flammable and inflammable mean the same thing. So in your exam, you have to know that flammable and inflammable mean the same thing, that it catches on a flame. It can burn if there's a flame. So we wouldn't want that when we are separating something. So alcohol, for example, if you're heating alcohol or if you're heating most of the organic substances, then make sure that you use a hot plate or an electric heater. But if you're heating a water solution that has salt like this one, then Bunsen burner is fine. Bunsen burner is cheap to use and it's really easy to control it. Electric heater is in fact better at controlling because you can actually use a thermostatically controlled electric heater. You can fix the temperature that you want to heat things to. So yeah, that's a good idea for that. All right, so That is if I have solid that is soluble and a solvent that I want to separate. What if I have more than one solvent? Then I will use fractional distillation. This process is called distillation. Notice that in the conical flask right on the right, there is the word distillate. That is for things that are collected after distillation. Just like things that are collected after filtration are called filtrate, these things are called distillation. So in the exam, they might ask you for a 3 to 4 mark question about outlining a way to distill a liquid, separating it from some solid that is soluble, of course. Now, the next thing is, what if I have something that has different uh, liquids mixed together? So in that case, what I would want to do is maybe use a fractional distillation. Now, fractional distillation setup looks something like this. Yes. So what's happening here? Again, it's a very basic example. You can clearly see that there is Bunsen burner, which is the source of heat. There is a round bottom flask with some liquid in there. And then there's this thing with many beads in it and many mesh kind of thing in it. That's basically a mesh with large surface area. So what's happening? Basically, the liquid is being warmed, it goes up, gains kinetic energy, evaporates, fights the forces of attraction, goes up. And then the fractionating column, it hits it and absorbs some of its energy. And the liquid now condenses back. But what if there's a liquid that has already boiled, that has enough energy to boil? It wouldn't condense back. It just keeps on going up where the thermometer is, and it goes into the other condenser. And that is where it cools down and it becomes a liquid. All right, so when things start to boil, they're able to go all the way, but other things are kind of coming back. So fractionating column is like a filter for vapors. Okay, it allows some vapors to go out, but some it stops. Obviously, the size of the fractionating column helps. If you have many mixtures, you would want to have a very big fractionating column, like when you separate crude oil or when you separate air into different substances. Air, as you know, is a mixture of nitrogen, hydrogen. So you just separate nitrogen, oxygen, argon, those kind of things. So you separate based on their boiling point. Again, what quality is this separating or based on? This is based on the idea of boiling point. So things with different boiling points, you're able to separate them. Of course, again, the source of heat that you use is important. For example, if you're working with crude oil, you wouldn't heat crude oil using an open flame. You might mask it using some other way, like they use in refineries. So it's important to make sure that safety is paramount, and after that you start separating things based on this boiling point, this difference in their boiling point. Okay, so that's the basic idea of how you separate things based on their differences. So we have already talked about dissolving, decanting. Decanting is simply pouring that thing off. Centrifuge is something that you use a machine to do it, usually not tested in O levels or IGCSE. Evaporation, when you want to evaporate a solvent and you leave it out in the open, the liquid can go away. If you heat it, the rate of evaporation faster. And yeah, then you have filtration, you have separating funnel. We have already talked about chromatography. Distillation, there's two kinds of it. When you have things that are different phase, like different states, then you use simple distillation. But things that are in the same phase or same state, you use fractional distillation. The three important applications of that: crude oil, ethanol, and separation of gases from the air. I will share notes with you on that, and it's a pretty straightforward process. And yeah, that's it. That is the idea of purification techniques. What kind of heat source we should use, that's also important. And of course, you can exploit the different mixtures that you have based on this. I'm going to share a test with you for now, and I would suggest that you use the remaining time of the class to make sure that you attempt this test. So I'm just sharing it with you on the chat that we have. So this test will have 15 questions and you will have 15 minutes to do it. Make sure that you solve it and I will share the video of solution of this test with you later tonight. All right, take care. Thank you so much for attending. I hope this helps, and I hope that you're able to answered any questions that you might have had. There you go. Please attempt this test. I'll see you in the next class tomorrow. Allah Hafiz.